Before we go further, let me introduce my teammates. First, we have Muhammad Nabil Arif bin Azmi Sharizal. Next is Naufal Bahim bin Sufyan, and last but not least, Muhammad Safwan bin Mat Sabri. And here is a distribution of work among team members.
Introduction. The fabrication of turbine blades requires highly accurate machining process to achieve optimal strength and performance. Techniques like turning, milling, and drilling are applied to form the precise blade geometry needed to withstand extreme speeds and high temperatures. High quality machining is essential to ensure the blades operate efficiently and reliably in challenging turbine conditions.
We need to know safety equipment during workshop.
Woo!
Next is a safety equipment during welding session. First, we need to wear a safety glove first. Next, we need to wear a welding helmet. Third, we need to wear workshop jacket and safety trousers. And last, we need to wear a safety shoes.
I will be explaining the complete manufacturing process of our turbine blade, step by step from raw stock to the finished product. We started with measurement using vernier calipers to measure the raw material. Next, we cut the material with a bandsaw, shaping the stock closer to final size. After cutting, we did lateral machining. This step shapes cylindrical parts like shafts, ensuring they are perfectly round and concentric. Precise turning is especially important for parts that rotate at high speed, like turbine blades. Next came milling. Using an end mill tool, we flatten surface and cut slots into the parts. This ensures that every component has the exact shapes and size needed to fit together correctly when assembled. With surface prepared, we move on to drilling. This step was done with both bench drills and vertical milling machines to create accurate holes for the screws and blades. Positioning these holes precisely is crucial for proper alignment during assembly. Once all the parts were ready, we used welding to spot weld the blade onto the plate component. We made sure to follow strict safety measures at all times by wearing protective gloves, welding helmets, and fire-resistant jacket to keep everyone safe during the welding process. Finally, we did grinding to remove weld bits and smooth out the surface. This not only improves how the component look, but also helps align the parts properly and ensures a clean, professional finish.
Next, problem that we face and their solution.
The first problem that we face in this project is blade short and shaft does not mesh on slot. The issue happened because the blade was too short, which caused the shaft to misalign and not fit correctly into the slot. On top of that, there was a dimensional error in the manual, which affected the accuracy of the shaft and hole alignment. For the solution of problem 1, to fix that, we cut a small section from the middle of the shaft to adjust for the short blade length. After that, we remeasure the shaft and hole dimension using precise tools to ensure a proper and smooth fit between the shaft, plates, and blade slot. For the second problem is milling drill bit broke during machining. The milling drill bit broke during machining because the depth of cut was too deep and the milling speed was too high. This incorrect setting causes too much force on the tool, leading to breakage. The solution for problem 2 is to fix that. We reduce the depth of cut to a safer range, around 0.4 mm to 0.6 mm per pass, to avoid the overloading the tool. We also lowered the milling speed to reduce stress and heat during the cutting process. This helped ensure smoother machining and prevented further damage to the tool.
Another issue was that the screw hole between the plates were not parallel. The plates were slightly misaligned during making. Our solution was to compare measurement for both plates and use a jig to ensure hole alignment before drilling.
For problem 4, we encountered an issue where the blade gutter was not parallel. This problem happened because of misalignment during the milling process. When the workpiece or the milling cutter is not properly aligned, even a slight deviation can result in the gutter being uneven, which can affect the assembly of the final product. To solve this, we use alignment fixtures to hold the workpiece securely in the correct position throughout the milling operation. These fixtures ensure that the parts stay in place and do not shift due to vibrations or cutting force. Second, we constantly measured the parallelism during the process. By checking frequently, we could make immediate adjustments if we detect any misalignment, maintaining the required tolerance. This approach significantly improved the accuracy of the blade gutter, reduced rework, and ensured a better fit and function for the final assembly. The last problem is time delay when making the turbine blade, mainly because there were too few machines available and we had to wait for others to finish using them, which caused unnecessary downtime. To solve this problem, it is important to provide additional machines to increase production capacity and reduce waiting times. Additionally, implementing an efficient schedule system will help allocate machine usage properly, showing that all machines are used optimally and production delays are minimized.
Next part is improvement that can we have from our project.
The first improvement is using stronger and more durable materials. One important improvement is to use stronger and more durable materials, especially for parts like the shaft and the cutting tools. Weak material can cause issues like the shaft not fitting properly or tools breaking during machining. This problem affects accuracy and waste time. By using higher grade steel or more resistant cutting tools, we can reduce wear, improve precision, and avoid rework. This results in a more efficient process and better quality in final product.
Secondly, switching to CNC machining or using precision jig can greatly enhance dimensional accuracy. This can solve problems such as misalignment, non-parallel holes, and uneven surfaces.
Lastly, implementing digital measurement tools can greatly improve the quality control of a work. Using digital calipers, micrometers, and alignment gauges can help to get a precise measurement. The advantage is that real-time data helps us detect any deviations early in the process. This ensures smoother assembly, better fits, and fewer reworks.